I think we can start now, like 6:15. So, like, is there anyone important who wants to join?
Okay, now let's start. Good evening, one and all. Hope all are doing great. Welcome to the webinar session on Hyperloop organized by IEEE VTS SB NSSCE. With great pleasure, I am introducing and inviting our esteemed speaker, Mr. Harikrishna T, who completed his BTech in Electrical and Electronics Engineering from NSS College of Engineering, Palakkad in 2019. And as of now, he is doing his MS in IIT Madras. And also, he is the electrical lead at Avishkar Hyperloop, a passionate student lead team at IIT Madras. And they are the only one Asian team to get shortlisted among top 21 out of the 1,600 plus teams in Asia, in 600 plus teams for SpaceX International Hyperloop Port competition. Once again, I welcome all the participants to this event, and let me hand over the session to our beloved speaker. Sir, you can start.
Not sure why is it echoing. Is it echoing now? Okay. Hello. Hello. Is it fine now?
Yeah, it's fine.
Okay. Hello. Good evening, everyone. So first of all, thank you for giving us such an opportunity to present here. So myself, Harikrishna. So I am the electrical lead of the team, Avishkar Hyperloop. So along with me here is my friend Jaikar Reddy. So he is the propulsion lead of our team. So we both will be handling this session today. So thank you for coordinating this event and inviting us to present. Yeah. So yeah, now Jaikar will be starting off with the presentations. So I think we can have it a bit interactive. So if you have any questions or something, you can just stop us anywhere and like you can ask, we will clear the questions and go. So yeah, now Jaikar will be starting.
Hello. So yeah, myself Jaikar Reddy, like Hari has introduced. So we are from Team Avishkar Hyperloop IIT Madras, as Hari has told already. So by the end of this presentation, I hope you'll understand a little bit about what Hyperloop technology is all about. That is one thing. Second thing, what we have done, how we started, what has been our journey, and what's the progress we have made so far, what we still have to do, what our goals are. And I hope by the end of this presentation, you are inspired a little bit to start something yourself in your college. So yeah, I think we can. We are basically a student-run team. So that means that every year we recruit students. Every year we recruit a certain number of students. Every year, people who graduate leave the team. So this keeps the ideas flowing and it keeps the enthusiasm on all the time. So yeah, I think we can go to the next slide. Yes, so to begin with, what Hyperloop is all about. So Hyperloop is basically trying to eliminate all the. So it's a train. It's like a train, but then we're trying to eliminate all. So first, it's like a train but electric, and then the second thing is we are trying to eliminate all sources of drag. So what are the general sources of drag in any moving vehicle? Like I think that's pretty obvious. Now one is friction due to wheels, and the second is due to aerodynamic drag. So friction is something which has been explored by maglevs. Maglevs already exist in China, Japan. They're operational, actually commercially operational. So there is something called in Shanghai there is a maglev which is currently operational, and there are few in Germany and Korea as well. So yeah, these are some of the maglevs which are operational. Maglevs are basically levitation, which so the whole train is levitating based on electromagnetic technology. And then the second, so this eliminates drag. Although the magnetic levitation itself introduces some drag, it is not as huge as the frictional drag. And the second thing is aerodynamical drag. This is slightly harder. For this, we'll have to run the entire pod in a vacuum chamber. That's the major idea. So the best part about this is if everything works out, it's very sustainable because it's completely electric. So the carbon footprint per journey would be very less. The numbers are right here. So the total distance travel time for, let's say, Chennai to Bangalore, which is a pretty common, people travel between these two cities quite often. So you can see that the average carbon footprint for the journey would be all close to zero, and currently it's almost 27 kg of CO2 per passenger. So yeah, so this would be the major, and the next major thing is the speed. So the speeds currently which airplanes offer are they are comparable to Hyperloop, but then the problem is it's the travel itself is very uncomfortable. It's not as effective as like you'll have to wait a long time in the airports, and yeah, that is the main problem. And currently making electric airplanes is not that effective as well. Like the technology is not there. Hyperloop would comparably take lesser energy to travel between two places. Yeah, so about the team, I hope, like, did you guys get an idea about what Hyperloop is, like a basic overview of why? I think anybody can respond. Okay, if nobody responds, I'm assuming you can put doubts in chats as well. Cool. So now about the team itself. So we started way back in, if I'm not wrong, 2017. If I'm not wrong, yeah, okay, 2017 is correct. And this was so initially when we started, we had about, I think, 20 to 30 people. And then back then they were ideating on all the technologies required for Hyperloop to be successful. And then that took about a year, and then then we realized that we are trying to fit in too many things too early, like we need to go slower. So then we started from the base. So we started from basic things like chassis. How do we optimize the weight? How do we decide on the power required for a battery? Like such basic questions we started to answer instead of directly jumping to what are the technologies required, like non-contact propulsion and how do we levitate. Those are more complex questions. If we start off with that, it would be harder to answer it would be harder to make any progress. Yeah, so that was in September 17, and then 1 year this ideation happened, and then 18 to 19 we manufactured our first pod, which went to SpaceX, and I'm pretty sure the photo is pretty famous where we had taken a photo with Elon Musk, our team, and this was the pod which had been selected for the SpaceX competition, and it was representing Asia actually, not only India. So yeah, that was 19. And then 1 year we ideated for another pod which had levitation technology and non-contact propulsion, but then this was kind of not implemented because that's when COVID kicked in. And then we had and then this was my year. This is when I joined, Hari and I, both of us. So this 2021, this is when we designed and implemented and participated in EHW. So this here we basically the main technologies we implemented were, so all the basic technologies were chassis, etc. And then the main selling point was non-contact propulsion. And then another thing which we also parallelly did during 2020-2021 was we designed a tube. So the main part along with the pod is a tube, right? Vacuum chamber. So the tube should be able to handle a lot of atmospheric pressure which is being applied on it. And not only handle it, it should be cost effective because this tube is going to be laid over hundreds of kilometers. So so that's where so till now whatever tubes had been manufactured had been very thick concrete, and it was very costly. So that's where our infrastructure team steps in, and like they had designed a novel prototype which was patented. it was a very cost-effective design. So, and that's when we not only designed it over this short 1 year period, we also managed to manufacture it, and we are also currently testing it. And now we also, I think this will come in the later slide. We also managed to receive funding from the Railway Minister, about 8.3 crores for the tube to be laid over 500 meters and run our pod. Yeah, so this is about our journey so far. So acclamations, yeah, I think here is the photo I was talking about. Here is the photo I was talking about with Elon Musk and our team. That was only Asian finalist, like I said, and this was in 2019, the SpaceX Hyperloop pod. And then comes 2021, which was when, yeah, this was the year Hari and I joined the team. This was the most scalable design award we won at ESW. There were, yeah, we were in top 5 category, top 5 in several categories, such as we were in top 5 of propulsion, levitation, mechanical, and electrical. That is almost all the subverticals of all the awards they were distributing. And then yeah, we also got to meet the Railway Minister. That was a huge plus point for our. I mean, that was a huge contribution from his side. Like, that was a huge achievement for us as well. He not only agreed to meet us, but also very generously told that he was 72nd member of the team, and we got 8.73 crores funding from him. So that is actually completely for the tube, but that is a huge win for us. Yeah. So team 5.0, yeah. So currently this is the team which would be working on trying to build a pod which would work in the tube. So it should work in the vacuum chamber and implement levitation technologies as well. So in the previous pods we had presented, levitation was not implemented. Although we had many levitation test setups. Like we tried 2-3 technologies, and we had a couple of test setups, but then we didn't integrate it with the pod. So this year that's the main focus. So yeah, hopefully we get there. So yeah, I mean, I have talked so much. Just wanted to know what did you get from this presentation? Like, whatever I've said so far. Like, what are the main technologies which are proposed in Hyperloop Transit? Could anybody just type in the chat, or I'll wait until one of you answers. Low pressure vacuum, yeah, that's correct. So low pressure, we need, so the first thing, maintaining the vacuum over hundreds of kilometers. Second thing, the tube should be able to take that much pressure. That is 100% correct. And all the technologies we are using inside, like let's say any chips or any batteries, they should be vacuum compatible. Yeah, that is one thing. Are there more general technologies which are generally? So what is preventing frictional drag? Okay, so basically friction is being prevented by levitation. So levitation, there are 2-3 mechanisms through which it can happen, all of which are mainly based on electromagnetic levitation. And then, so not only levitation, once we levitate to propel, usually propulsion happens through wheels, which are contact, like they need to touch a surface to propel, but then we need contactless propulsion as well. So I think Hari will soon in the later slides explain how this exactly happens, like what are the kind of motors we use and how exactly we achieve both levitation and propulsion. But for now, yeah, these are the main ideas. So low pressure vacuum, contactless propulsion, and levitation. So I think Hari can take over now, and he'll explain about the technical parts of the team and what we are considering.
Yeah, hello. And so I hope, yeah, you guys understood something from whatever Avishkar has explained in such a short time. So this is our team basically. So our team mainly consists of, as you know, that Hyperloop has to be a combination of lot of engineering disciplines. We also have 4 main verticals in our team. So the first one is electrical, and in electrical we have all the power electronics and also the embedded systems of the team, where the control systems of the entire pod happens. And second vertical is electromagnetic. So in electromagnetic, as you know, that everything is mostly electromagnetic, the motors, the levitation and braking. So we have a separate wing of electromagnetic, and of course the mechanical subsystem. So in mechanical subsystem comes most of the structural part of the entire Hyperloop system. So where we have chassis, infrastructure, aerodynamics, and stability. And then comes the business. So business is also a very important part of our team, where they help us in getting the funds, and they also do case studies on how the future tech can be, and all those things. So yeah, so from now I'll give a very basic idea of what each subsystem does in our pod, and how are we implementing these technologies. So first thing is propulsion. So propulsion, if you know that we cannot have rotary motors. So if we have a rotary motor, we should actually have a belt mechanism to put it in a wheel, and then we should move. So as we don't have wheels, we should propel contactless. So for contactless propulsion, we have chosen linear induction motors. So linear induction motors are simply like rotary motors, where we cut a motor and open it and keep it flat. So I hope you can understand by seeing the picture. So in the right side picture, if you can see, there are two linear induction motors. So they are called double-sided linear induction motors. So what we do is we mount it in our pod, and we have an aluminum rail in the middle. So by that will act as a rotor, and we will have the stator. So by the combination of both, the pod starts moving. So as of now, we have designed linear induction motor which can accelerate our pod at a max acceleration of 4.6 meter per second square, and we were able to achieve an efficiency of about 60%. And then comes levitation. So in levitation, as we know that levitation is one of the most important parts of a Hyperloop system. Without levitation, it's not possible to build a Hyperloop system. So till now, we have not yet implemented any levitation techniques in our pod. So till now, we have done many bench scale setups for our levitation system. So this is the year where we are trying to implement levitation in our pod. So if we can successfully implement levitation, we will be the first team in India to have a levitating pod. So this is the front view of the pod which you are seeing here. So in that you are seeing that EMS is written. EMS means electromagnetic suspension. So what happens is, when we pass current through these two EMSs, the pod will lift up. So we use certain kind of control system techniques to maintain the levitation position. So like that, we will be able to achieve levitation. So hopefully we will be implementing successfully levitation this year. Yeah, so that is the whole idea. So this is the more close-up image of the levitation system, where we have the iron track on top, and we have our levitation system in the bottom. So by controlling the current through the coils, we can control the levitation force, and we can make the pod levitate. And this is the small idea of the test setup which we are building for levitation. Before implementing in the pod directly, we always test it out in small test setups, so that we can ensure it's working, and then we go to implement in the pod. So this is an idea of the test setup which we are building for our levitation this year. So high power system. So high power systems is one of the key parts of our system. So where we work on batteries for propulsion and complete energy of our pod, and also our inverter. So inverter is required to convert DC to AC to propel our linear induction motor, and also we work on DC-DC choppers for our levitation. So this is our inverter which we have built last year. So which has a capability of maximum of about 400 volts and 600 amps, and we work on closed loop V/F control to propel our pod. And also we have this year a current controller for our levitation. So the schematic diagram of the levitation controller is shown here. So where we have a DC-DC converter to control our current for the levitation. So it can operate at a maximum of 600 volts and 75 amps. And embedded systems. So embedded systems is one of the key units in our pod. So they take care of all the controls and all the communication aspects of our pod. So we have something called graphical user interface in our laptop, which will be far away from where the pod is. So we will communicate from our pod, from our station to the pod, and the pod, all other communication inside the pod will be taken care of embedded system, and all the control and safety is taken care. So where we have a master control unit, and master control unit actually communicate to all the subsystems, if you can see here, like inverter, levitation, embedded systems, and BMS, cooling, braking, everything. So like this, they are the brain of our pod. So this is the control architecture you are seeing here. So one of the key challenges we have in embedded systems is we cannot, as you know, the tube is an it's a chamber where where electromagnetic waves can't come out. It will be very difficult to communicate. So any GPS or anything won't work inside a tube. So we are trying to figure out some kind of technology where we can find the accurate position of the pod without using any GPS. So that is one of the key bottlenecks in implementing Hyperloop technologies. So braking. So when we come to braking, you know that like most of the almost all the vehicles use friction braking for stopping the vehicle. So in friction braking, like you know that two pads will come in contact with the whatever disc is there, and like it will generate some heat and stop the vehicle. But as you know, Hyperloop is a technology where it goes at like almost 1,000 km/h. We cannot have any braking with contact. The wear and tear will be large and the heat production will be very high. So that's why we came up with an idea called electromagnetic braking, where we have magnets. If you see in this figure, these two things have magnets inside it. So when it comes closer to our aluminum rail, it will generate eddy currents and it will stop the pod. So we have that is generally known as non-contact braking. So yeah, so this is the braking setup. So the braking is contactless and we don't have wear and tear, and it is we have redundant mechanism. So in case of any urgent scenarios also we can stop the pod. So this is the total force which we have achieved till now, which is around 2 kilonewton. So which is a huge amount when compared to other braking mechanisms. chassis. So chassis, I think everyone knows, like all the vehicles and everything needs a chassis. So chassis is where we mount everything, all our systems like batteries, inverters, like embedded systems, suspension, everything comes on top of chassis. So the design of chassis is very critical. Like it should take all the loads which we are giving and everything. So this is the design of the chassis which we are going to build this year. So it is made of aluminium, and these are the dimensions, and its mass is about 46 kgs. And yeah, you can see this is the first iteration we had of the chassis, like when we started long back in last September. And this is where we are now. We have almost finished our design and we have given the chassis for manufacturing. And this is the holder for our EMS, which we have seen before. Okay, so yeah, this is the holder for EMS, and this is the holder for LIM. So LIM, you know that like it should be in close contact with our aluminum rail. So that's why we have a more like holder where we can adjust our air gap, so that we can adjust the distance between our aluminum rail and the stator of the linear induction motor. And then comes aerodynamics. So you might be wondering, why do we need aerodynamics? So aerodynamics, like as it's operating vacuum, there should not be any air, so we won't require aerodynamics. So actually it's not like that. So like it's economically impossible to maintain complete vacuum. So wherever we are operating, there will be a certain amount of air. So that it's a optimization thing. So we are we are trying to optimize on that and trying to find out an optimum pressure where we can operate. So actually we can't operate at 0 pascals. So as of now, we are doing all our testings at a pressure of 1000 pascal, which is almost 1/100th of the atmospheric pressure. So for eliminating the drag on that pressure also, we are having aerodynamics. So in aerodynamic subsystem, they generally design the shell of our pod and they test it in wind tunnels, and they come up with results on how much drag we are getting and all those things. Suspension. So like as we told that till now we have not yet implemented levitation on our pod. So we are using suspension. So in suspension we have we have semi-active suspension, where we have a distance sensor to measure the distance between the rail and our pod, and we will give control signals to adjust the damping forces. So this is the suspension test setup which we are building this year to test out our dampers. So I hope like it's a bit difficult to understand, but I hope some idea you got. Infrastructure. So infrastructure is one of the key parts of Hyperloop. So as Jaker has already told, like infrastructure constitutes of all the major like almost 80% of the cost of Hyperloop goes into infrastructure. So that's why people are a bit skeptical about like where will Hyperloop be a reality or not. So that's why we came up with our own infrastructure and our own tube technology, so that we have to like reduce the cost of the infrastructure as low as possible. So like as you can see in this slide, we have come up with a design where we need almost 5 to 7 million for our tube for 1 kilometer. So these are the prices of other teams and other European teams, where the infrastructure is about 38 million and 24 million. So this is one of the key focuses we are doing, and this year we are trying to build a 500-meter long tube in our satellite campus of IIT Madras to check whether all our simulations and results are correct. So as I was telling, like we cannot maintain a perfect vacuum. This is the optimization curve. So where we have the amount of energy required for vacuum and the aerodynamic drag. So we should find an optimum point so that like we can operate efficiently, where we should not take a lot of energy to evacuate the tube, and also we should not have a lot of drag on the pod. So it is coming out to be around 100 to 2000 Pascal. So as per our analysis till now. So we are working on it further, and we will be improving, and we will get a final value for that soon. And infrastructure track. So not only tube is a very big part of Hyperloop system, the track which the pod should run is also an integral part. So as you can see that like these are the previous tracks which we had in SpaceX competition and also in our European Hyperloop week. So as you can see, it is kind of an IE beam. So where the pod runs here. So soon we have found out that this beam is not very much like kind of scalable. So if you go for a pod which is about 20 tons and like where it is going at 600 km/h, these kinds of tracks won't work. So then we came up with our own track technology. So that's what I think you have seen in the slide of Chasey. So this is our track. So in which we have the aluminium beam in the middle, and we have the support structures for levitation in the sides. So this is the technology which we have come up this year, and we are in our process to build our track to test both our levitation technology, and to put it inside our tube and test our tube pod inside vacuum also. So this is a cost-effective technology. We have tried we have done a lot of redundancies to like also to ensure the safety of the entire thing. So business. So as I have already told, business is one of our key parts. So whatever funds we require for all our technical things, and whatever exposure we need, and whatever help we need from outside world, business team help us to get us through that. So railway minister and everyone, all those things were done by our business team. And social medias and all those things are also handled by our business team. So business, and they do case studies like what will be the approximate cost Hyperloop technology will have when we travel from Mumbai, like Chennai to Bangalore, and all those things they do. So this is the 4.0 pod which we have built and like which we have tested successfully. So this is the pod which had won the European Hyperloop week, like most scalable award in European Hyperloop week. So these are all the systems which we had. So if you can see here, this is our chassis, the black thing, which is made of carbon fiber. And here comes our suspension, and we also have wheels. As I told, we have not implemented levitation on our pod. We have wheels to support our pod. So these are driven wheels. So the propulsion is given by linear induction motors, which is contactless, and you can see here. And the power for the linear induction motor is given through this inverter, which is located here, which converts the energy DC power from the battery pack to three-phase AC. So this is the battery. This is our battery pack. And this is our braking mechanism. So where we have pneumatics to actuate our brakes. So here is where the brake actuators are implemented. So you can see here the brake actuators. So we use pneumatics, and we use the control systems to control the pneumatics accurately and brake whenever we need. So this is our control system. So they communicate with all the systems in our pod, and they ensure the safety of our entire pod. So, and this is again the suspension in the front and rear of our pod. And this is our linear induction motor in the top view. So you can see here there are two motors on both the sides, and we will be having our aluminium in the middle of this thing like this. So wherever linear induction motor will propel this thing, and whenever required, we will brake. These two brake actuators will come closer to the aluminium rail, and it will help in the braking process. There is a video here, but it's not. 1 minute. So this is the pod run which we did last year in our campus. So with all the technologies which we have explained now. So yeah, so this was done at IIT Madras itself, wherever we are now. So this is the back part of wherever we work. So we have laid our own track of around 60 meters, and we have run our pod. As we don't have a tube and a tube, so we are testing everything outdoor as of now. So soon as we have got the funding, we will be moving indoor and we will be testing all the things inside a tube under vacuum. So in this we have tested for 35 meters for an acceleration of 0.5 Gs, and we have achieved around a speed of 40 to 50 kilometers per hour. Yeah, so this is the pod 2022, the which ran just now, like the video which you have seen. So which has contactless propulsion, contactless propulsion. So this year we are planning to build pod 2022, in which we have same contactless propulsion, regenerative braking. We also want to try regenerative braking so that like we can get back some of the power which we are using for braking, and we are also trying to implement on levitation and in-house control systems and semi-active suspension. And thermal management is also a key part which Hyperloop needs. So we are starting off to work on that from this year. So hopefully by next year we will have some results on that. Yeah, so this is a small video. So where we are revealing our tube. Yeah, so this is the reveal of our 500-meter vacuum tube which we will be building this year. So like as we have got our required fundings, we are going to start the manufacturing process soon. So we will be starting it off in a couple of months. So yeah, so it's a 500-meter tube with 2 meter in diameter. So this will be like one of the largest student-run Hyperloop testing facilities in across the world. Only two other companies have testing facilities as of now. So this will be one of its kind in India also. So where we are planning to test our pod until a speed of 300 kilometers per hour at our new campus of IIT Madras in Chennai. So yeah, as we are going to build a 500-meter tube, we have also built a small scale setup to test the technology, as we cannot directly go and build a 500-meter tube. So the small scale thing which we have built had a length of 3.6 meters and 1 meter in diameter. So in that we have understood the complete assembly and manufacturing difficulties, and we are planning to improvise on that and make it a bit easier based on the results. So this we have tested up to a pressure of 0.997 mm of HD. It's almost 0 Pascal, and we have achieved a leakage rates of 1300 pascals per hour, which is like quite good actually. And this was inaugurated by Pawan Goenka, who is the director of InSpace and also one of the governors of IIT Madras. So journey of Hyperloop. So like this is some of the future like things which we are planning to do. So hopefully we will be able to achieve these kinds of timelines. So in the phase 1, we are going to build a 500-meter tube. So that started in summer 2022. So which will be in 500 meter in diameter and 500 meter in length and 2 meter in diameter. So after our small scale test in the 500-meter tube, we will be building a 10-kilometer track with 4 meter in diameter. So that will be like almost from 2 to 3 years from now. And we will be testing curves also in that, like we will be putting curves. So as like in Hyperloop, one of the major thing is like you can have sharp bends as it is traveling in very high speeds. So we will be testing out our curves and everything in this 10-kilometer thing. So hopefully by 2030, we will be building a 300-kilometer corridor between Chennai and Bangalore, where we can travel from Chennai to Bangalore in about 30 minutes. So yeah, this is the thing. So this is expected to be in 2028 to 2030, where we'll be demonstrating Hyperloop technology from Chennai to Bangalore. Yeah, so I hope we are almost at the end of the presentation. So these are some of the media coverages we have got, like when we have built all our pods and everything. And these are our proud sponsors, where Deloitte and Tube Investments India has been our title sponsors last year. This year we have L&T Technologies, Daimler, and also Indian Railways. Yeah, so thank you for our time. Thank you for your time, and like if you have any questions, we can move forward for that.
So, what are the risk factors of Hyperloop?
Okay, so the major risk factors of Hyperloop is that like tube only. So we have to like if you have a corridor between Chennai to Bangalore, like you will have a 300-meter like 300-kilometer evacuated chamber. So any small decompression which happens to that can be disastrous. So that is one of the major risk factors of Hyperloop, and something which is traveling in 1,000 kilometer per hour. As of now, only aeroplanes travel around 800 kilometer per hour. No, I think nothing else travels in 1,000. So something which is traveling in 1,000 also will have a lot of forces and things which we are yet to discover and see. So most major risk factor is to maintain the vacuum for the entire 300 kilometer per length, like, and ensuring the complete safety of everything.
Okay.
So, to what extent will Hyperloop be successful in rural areas?
Okay, Hyperloop actually is not meant for rural areas. Hyperloop is like actually meant for cities where you have large number of passengers traveling from one city to another, like Chennai to Bangalore, Mumbai to Pune, or like that. So where you have a very large number of people traveling, and like you want to get them through as less time as possible. So if you see in aeroplanes, if you want to go from Chennai to Bangalore, like you should wait in the airport for 1 hour. Again, aeroplane will have some time in the airport running to the runway and all those, and you will go to the next airport in Bangalore, and it will also take some time to get departed from there and come out of the checking and everything. So in Hyperloop, if you see like an airport, if you know that Bangalore airport is also not in Bangalore, so like you have to spend some time from coming from the airport to the city center. So Hyperloop is such that like you can board like a metro, and you can go inside, and it will be connecting both the city centers. So you can directly go to city center of the Bangalore from the city center of Chennai in about 30 minutes. So it is not meant for rural areas actually.
Yes, sir. Thank you.
Sorry, I didn't get that. Sorry, I didn't get that question. Mostly it will be around 30 to 40 passengers per pod. It will be like as per our throughputs which we have come, like which we have analyzed and got till now.
Hi, sir.
Yeah, hello.
what will be like the ticket charge? Will it be affordable to the common people?
Yeah, we want it to be like, as of now, as per our predictions, it will be around like, if you take Chennai, Bangalore, it will be around 1,500 to 2,500 per passenger. So it is not very cheap, but like as time progresses, like bus and other trains, it can become cheap. So as of now, the prediction is 1,500 to 2,500, where it's not very expensive also. So we thought like most of the people can afford it, and you can reach it in 30 minutes also. So that is also another key point. So it will be affordable for the passengers.
Thank you, sir.
Sir, will there be any emergency exist and what they do? Like, that is, how can the safety be guaranteed in Hyperloops?
Yeah, like as I told already, like safety is one of the key things which we have to see. So safety, like there is a lot of things to work out in safety. So like as if you can ask like some emergency exit kind of questions, I think like it's very like precise question, like which is very difficult to answer at least at this point of time, which we have to see later on. So like as it is an emerging technology, there is no like standards available. So if you see aeroplane, there are a lot of standards available, like you should have this kind of safety, you should have this kind of safety. So as Hyperloop is a completely new thing, we have to build our own standards. So if you see American, like there are a lot of American companies and European companies, they are trying to build the standards for Hyperloop. So first we have to build the standards on how Hyperloop should be and what kind of safety we should ensure. So once the standards are built, then we will come to the question where how can we implement those standards actually. Okay, so I think there are two questions. First thing is it's a pure vacuum. It is not pure vacuum. It is like it will be around like 1/100th of the atmospheric pressure, because maintaining pure vacuum is economically infeasible. Major softwares which we use for design and simulations are mostly we use ANSYS. If you see electromagnetic motor simulations and also levitation simulation, we use ANSYS Maxwell. And also the mechanical people also use ANSYS mechanical for their simulations. So most of the simulations are done in ANSYS only. Also aerodynamic simulation is also done in ANSYS. We sometimes use COMSOL also. And also if you see the power electronic simulation, we do in MATLAB Simulink. And the digital circuits are done in LT Spice software. So I hope this answers your question. Is Hyperloop under Tesla? Means like as of now, Elon Musk, Tesla is not working on Hyperloop. Tesla is only working on electric cars, is my knowledge. Hyperloop doesn't come under Tesla. And shape of the pod will be like a small, some 20-30 meter long bogie kind of thing. So like if you have seen here, like it will be something like this only in the aerodynamic presentation, like slide. It will be something like this mostly.
So what are the possible accident chances of this transport?
Okay, so most of the accident things, like in the safety part, if you see that tube decompression can be is a very catastrophic thing. Like if something happens to a tube and one part of the tube suddenly decompresses, that can be very much catastrophic. And one more big accident possibility is that like if lot of pods travel in a certain distance, if something happens to one pod as it is traveling in very high speeds, there is a possibility that it can collide with the other one. So the control systems and the tracking of the pods should be very much accurate so that we can avoid those kinds of accidents. So these are the major things which we can see as of now.
Thank you.
Yeah, Hyperloop, if you see, like if you want to think in terms of speed, it is not very fast as per the train, like as I have told already, like the train in like domestic planes actually travels around 600 to 500 kilometer per hour, but like in the international planes travels in around like 800 kilometers per hour to 900 kilometer per hour also. So like Hyperloop is not very much faster, but the advantage is like you can save your time in the airport. So if you know, if you want to board a train, you have to go to the airport 1 hour before you do check-in and all those things. And airport is also located far from the city centers because it covers a very big land area. So the major time consuming part is it is a bit faster than the plane, and also it connects between two city centers. So you can reach the other city center very fast. So that is the whole concept.
The performance is hi sir, how many passengers can travel in Hyperloop? Like what's the maximum number of passengers?
Okay, so maximum number of passengers like per pod we have estimated to be around like 30 to 40 people as of now.
Sir, if it's 30 to 40, will that be highly inconvenient for bulk traveling?
Means like I didn't get your question.
Like in trains, we have like many passengers for a long journey, that is Mumbai to Bangalore, for example. In an aeroplane,
Hello, yeah. So basically, the thing is, the energy required to propel the pod would be very less. So, like we said, it's vacuum, right? So the drag is very less. So once we propel it, we don't need to keep providing energy to sustain the speeds. So due to this, we can increase the frequency of our pods. So it will take only 30 minutes to go from Chennai to Bangalore. At least that's the estimated time. So we can have pods at least at the frequency of 30 minutes. So that, I think that makes up for the number of people issue. Does that make sense? So we can have a lot of pods traveling between Chennai and Bangalore because energy is very less, and that makes up for the thing that each pod itself would be carrying less number of passengers. Yeah.
Yeah, like safety, like guaranteeing, I think I have answered that question already. Like safety is one of the key things like which we have to focus in any new like any new mode of transportation. So it can be guaranteed as such. So many people are working on these standards of safety which we have to achieve in a certain kind of transportation. So if you have the safety regulations for buses different from car, a safety regulation for a train is different from an aeroplane. So Hyperloop will also have its own safety regulations which like people from Europe and India, everyone are working towards. So we will come up with some kind of safety standards for Hyperloop, and once we achieve it, we will be good to go.
Sir, when will we launch the first pod in India?
First pod in India means like smaller pods are already done. Like Avishkar itself has done like two physical models of the pod. So we have two physical models. Other than this, we have almost four design models. So first pod in India has already come, but it's not like where the passengers are sitting and going. So we will be reaching that stage soon. Like hopefully, if you want to see like that in a vacuum tube, we will have a passenger run in about 2 years. Two years from now can be a timeline taken for that, where we can test first time with passengers in a vacuum.
So, can you say more about the SpaceX Hyperloop pod competition?
Okay. So SpaceX Hyperloop pod competition happened in 2019. So where Elon Musk called for all the teams across the world, like anyone can participate. So the competition was based on like to build a pod which can travel as fast as possible. So initially in 2018 also the competition was there, and like we tried to participate. So in that, like we failed to achieve we failed to be in top 48 in the world. So after that, like in 2019, we again participated and we built our own pod, the pod which we showed, like the first pod of Avishkar in 2019, and which was able to propel to speeds up to 200 kilometer per hour. So we took that pod to SpaceX, and like we were the only Asian team who got qualified for that thing, and we took that pod to SpaceX, and like yeah, we were around among the top 10 teams in the world also there. So that's how it was. We didn't win any major awards there because like the competition was only based on speed. So I think some Delft or some TUM University won the first prize in that competition. So after that, after 2019, SpaceX has not organized any competitions. So hopefully it might organize in a couple of years from now. So I hope that answers the question. Will there be a tie-up with Virgin Hyperloop? Like, no, there won't be any tie-up mostly with Virgin Hyperloop. Like, India will be developing India's own Hyperloop. So, like, there won't be any tie-up kind of things. So that's why railways are also supporting Avishkar for this thing, like, so that we can develop our own indigenous technologies.
Yeah, Hari.
Yeah.
I wanted to add one thing. First of all, regarding Virgin Hyperloop's tie-up, Virgin Hyperloop tie-up can happen, but then the value propositions itself are a bit different. The preferences are a bit different. We are more focused on cost. They are more focused on performance. But that aside, one of the key messages that I want to basically give out to other colleges and other students throughout India is actually the kind of opportunities that are there in the Hyperloop space. So we are currently building this 500-meter long facility, which is the world's leading facility. There's only one other facility, a similar facility, that is with Virgin Hyperloop. But that is a closed source facility. You cannot access it. No one else basically can access it. We want to create it as like a open access platform where everyone can come in, test their technologies, and we also want to have an international competition, Hyperloop competition at IIT Madras. So one thing that I really encourage all the students everywhere to explore is there's is an immense scope for student activity in this space, because of course student activity is especially important, and especially in Hyperloop, because this is a very underdeveloped field, and you need that kind of novelty in ideation that would be required, and the magnitude of the technology that has to be developed is also very humongous. So I don't think any one party or one team or someone is going to be able to do all this on their own. So that's why I think there's a lot of potential for student teams to come up, ideate on new technologies, test them out on a smaller scale, compete, have fun, get good resume points, and maybe even file few patents here and there. So yeah, that is something that I want to convey to everyone, that IIT Madras will be conducting a global Hyperloop competition, and we want everyone to participate in the Hyperloop space. Was that clear? I was audible?
Yeah, you are audible.
Hello. Cool. Yeah, sorry for I'm also a part of the team with Hari.
Yeah, he's our team head in Avishkar. Yeah, so that's it actually from our side. Is there any other student teams? Yeah, there are a lot of students team in India. Like there is one from Bangalore, one from Mumbai. There is a team at IIT Bombay and Delhi also. But like yeah, they are like growing. Like they are in a stage where we were about 2 to 3 years ago. So yeah, there are student teams in India other than Avishkar.
Yeah, these teams have also like recently started. They have not built their first spots. So recently only we have started seeing a lot of activity from other student teams, and that is like quite exciting. So it's not like someone has a long heads up on you, on anyone basically. This is a very new space.
Yeah, we have been motivation for many teams in India. Like as we have started first, we have the first go into one dates.
So, does anyone have more doubts? So, I think there are no more doubts. So, let's wrap up the session. That was fairly a great one. Hope you have enjoyed and learned the session very well. So, to deliver the vote of thanks, I am inviting Madhav Nair over to you.
Bye.
So, if everyone turn on their cameras, we can click a virtual click.
Last but not the least, I would like to thank all the participants present here for your active participation and attention. And certainly, we can look for another interaction in the future. A feedback form is provided in the chat box, so please do check out and fill the form before leaving the meet. Once again, thank you everyone. Stay safe and take care. Goodbye.